going to look at a couple of other derivatives that involve chain rule and really focus on how I could use some algebra to get the simplified version of our final answer, our final derivative. These are going to be a little bit trickier, a little bit more complex, because we're going to use chain rule, start differentiating some more complex types of equations. Let's do an easy one. Derivative of y equals x times square root of 3x plus 4. Y equals x square root of 3x plus 4. How would I go about finding the derivative of this function? What rule would be helpful? Obviously chain rule, because I have a composite function. The square root of 3x plus 4 is the composite, but what else?
Exponent.
We'll use power rule, sure. What is this equation made up of? What's the first piece?
X.
What's the second piece?
Square root of 3x plus 4.
And what's happening to those two pieces? So which rule should I use? Product rule. We're going to use product rule in conjunction with chain rule to find this derivative. Product rule should be the first times the derivative of the second, plus the second times the derivative of the first. Let's get working on that. dy dx equals the first, which is x. If you want to think of this as 3x plus 4 to the 1/2. So now we can use power rule. That would be probably a wise choice. I've got the first times the derivative of 3x plus 4 to the 1/2. That would be 1/2 times 3x plus 4 to what new power?
Negative.
Times what else? Where's the extra 3 coming from, Shaq? Oh, 3x plus. Go ahead, sorry.
I don't know.
I've just done one part of the product rule. First times the derivative of the second. Now let's add on the second times the derivative of the first, which is just going to be 1. Calculus work is over. All that's left is just a whole bunch of algebra to get the simplified version of our final answer. That's our focus today. How can I simplify to get the most basic form of this derivative? Best form of this derivative. So dy dx equals, let's see here, we're going to have 3 times 1/2, which would be 3/2 times x. So let's write that as 3x over 2. The negative exponent needs to go into the denominator. So the negative 1/2 power becomes positive 1/2 power. And put it back on bottom. Three times 1/2 makes the 3/2 here. We'll bring the x down and adjust the negative exponent back in the denominator. Plus square root of 3x plus 4. Let's start putting more of this together here. I want to add these two things together. Before I can add them together, What do they have to have? Before I can add fractions together, because one of them is a fraction, what do I have to have in place?
Common denominator.
So let's review denominators. 1/2 plus 1/3. What's common denominator? A sixth. So this would be 3/6 once I multiply top and bottom by 3. This would be 2/6 once I multiply top and bottom by 2. So 3/6 and 2/6 altogether is 5/6, right? So let's find common denominator from these two things. We'll put that over 1 so you can see what's really on top and bottom here. What is the common denominator?
2 radical.
It's just the product of the two denominators. The common denominator is a number that 2 and 3 both go into, so can I just multiply 2 times 3 to make 6? So I'm going to multiply an extra 2 root 3x plus 4, the top and bottom, in this second term, so that I can add these two together. So dy dx equals 3x over 2 square root 3x plus 4 plus, what's 3x, what's square root of 3x plus 4 times square root of 3x plus 4?
3x.
Just cancels out. When I take square roots times themselves, it cancels out. Square root of 2 times the square root of 2 is just 2. Square root of 5 times the square root of 5 is just 5. So the square root of 3x plus 4 times the square root of 3x plus 4 is simply just a 3x plus 4. I can add these together now, since they have common denominator. Putting these two numerators together, 3x plus 2 times 3x, that's 6x plus 3x, or 9x. Two times 4 is there should be final words. Some good review on product rule, as well as how to kind of add rational expressions together. Find common denominators and add all of those up. 9x plus 8 divided by 2 radical 3x plus 4. Where did this extra 3 come from? Is that what you're asking? It's the derivative of the inner function, 3x plus 4. Chain rule says I have to take the derivative of each part separately, then multiply them together.
Oh, okay.
This part is just the power rule part, where I bring down the
Yeah.
1/2 portion and replace the exponent. But isn't there also a function on the inside of that?
Yeah.
The 3x plus 4, I have to differentiate also. Got it. One more. Let's do y equals x. Okay, one last function to differentiate. Y equals x over square roots of 1 minus x squared. rule would be helpful as I'm trying to differentiate this function. We use product rule on this example, so here I'm looking at someone just said it, I think Maggie said it, quotient rule, right? Top and bottom, high and low. So if I sing the quotient rule to myself, it should be low d high minus high d low all over that low square. So putting this together, low, which would be the square root of 1 minus x squared. Let's just write that as 1 minus x squared to the 1. Let's think of this as 1 minus x squared to the 1 half, so I can use power rule. D high is 1. Below d high minus I, or x, times d low. This is the hard part. What's the derivative of quantity 1 minus x squared to the 1 half?
1 half times
So the power part, 1 half, go ahead.
1 half 1 minus x squared to the negative 1 half y.
Okay, so that's part of it. I differentiated the outer function, the 1 half power part of that composite. I also need to make sure I take the derivative of the inner function, which is going to be what? Negative, close. What's the derivative of 1 minus x squared? 2x. You got enough close parentheses there. Take it one function at a time. We did the power rule part here, but then don't forget to also multiply times the derivative of the inner function, the other function that makes up that composite. All over low squared. So square root of 1 minus x squared. Squared. Okay, there's our derivative. I want to work on simplifying this as much as possible because it looks pretty gross right now. 1 minus x squared to the 1 half times 1 is just the square root of 1 minus x squared. Minus x times a half times negative 2x. Let's multiply all those together. Negative 2x times a half times another x. What's negative 2x times 1 half?
Negative x.
Times another negative x is positive x squared. Since this has negative exponent, I'm going to put that into a fraction where it's in the denominator. On the bottom, when I square a square root, radical 1 minus x squared squared is simply 1 minus x squared. Here's our derivative so far. We got some more work to do to start cleaning this up. What makes it look kind of messy right now?
Got a fraction on top.
A fraction on top, right? So how could I clear out that fraction? How can I get rid of dividing by root 1 minus x squared? Multiply everything by. Take the square root of 1 minus x squared times another square root of 1 minus x squared. I'll take the second term, x squared over square root of 1 minus x squared times another square root of 1 minus x squared. And on the bottom, 1 minus x squared times another square root of 1 minus x squared. A lot of good algebra is going to start happening, because what is the square root of 1 minus x squared times the square root of 1 minus x squared? 1 minus x squared. Square roots cancel out. When I take this portion and I multiply it, when I'm dividing by root 1 minus x squared and multiplying by root 1 minus x squared, it's the x squared part. Now I need to multiply 1 minus x squared times the square root of 1 minus x squared. 1 minus x squared is to the first power. Square root of 1 minus x squared is a 1/2 power. When I multiply exponents, what do I do to the powers? So what's a half plus 1? 3/2. This would be 1 minus x squared. 3/2. One last thing to simplify. Pretty obvious. What's going to happen up on top? 1 minus x squared plus x squared. Cancel out. So final derivative, 1 divided by quantity 1 minus x squared to the 3/2. Nice trick when you're doing product rule is that if you have to add fractions together to simplify it like we did, you find common denominator. Sometimes when you're using quotient rule, if I want to get rid of fractions and fractions, I just multiply through with the common denominator. We'll start simplifying from there. Multiplying through with that denominator, and it starts simplifying nicely from there. All right, last 15 minutes or so, let's get some more practice pulled up.